Okay. Looking at this, it shows that I have 21 participants. I'm one of them in the class. As 20 of you guys, and it says only 9 of project 1, 9 were turned in, and 8 are drafts, and that's then it's saying in so many words. There's a few that aren't even there yet. The drafts, I'm not too worried about. What's going on? There's a button when you turn these in that you also have to say submit. Okay, and if you didn't do that, all it does is tell me it's a draft. I don't care. I can still grade it. If you haven't done it yet, or haven't completed it yet, it's still open. You can turn it in, but it will let me know. I'm all out of breath again. It will let me know that it's over. It's a little late. Don't worry about that so much. Just turn it in. Okay, I'm not going to extend any more of these because we're out of time. We're running out of time for the semester. So I can't extend a couple, maybe not, maybe it was in the distance class. A couple people have asked me to extend some more, and we just can't do it. Okay, the exam is coming up Thursday, right? It is. I did finally finish up a computer exam, so you guys will be able to take it online. You can do it wherever you want. If it would be great if I could get a lab for us or a room for us. I haven't done it yet, so I had thought about it until I just said it. So you'll just have to find a computer and do it. It would be easier if you guys were in these rooms here, like 225 or 229 or whatever, so I can walk around and see if any of you are having problems. The distance ed folks I'm most worried about, and I want them to hear this. There today in the or in the C class, 2 guys. You guys might not have known it that are in the C class, but 2 guys that were in there submitted it, and as soon as they did, everything went away. They had no answers. It cleared everything out and submitted nothing for them. How did on where? Where did it?
Homework and stuff.
On
it's
my
really
homework.
cleared out everything. I'll be doing it. I think it's because we pull up to look at like the PowerPoints or something, and we pull up or open up another one, and that's what it was doing. But I don't know why.
Yeah, I have no idea why some of it's doing it. It's here we are. I mean, UNCC likes to get your student fees that go for all the computing stuff. So they also buy the cheapest stuff they can get. Uh, I just was recorded saying that. I shouldn't have said that. But here it says experiencing difficulties with all this stuff. But that sign's been up there for like what, since the beginning of the semester?
Since the end of last one.
Okay, so now what I want you to do is if you're taking the test and you have gone to submit it, what you might want to do is as you're taking it, write the answers down on a piece of paper next to you.
Or you can start to submit it and it'll save the problem and then just go and return it.
How about your time? See, you might not have time to do all those things.
You're right. Well, there's 24 questions. You got about an hour and a half to do it. Not quite an hour and a half. You should be able to get it done but you're right. You have to move quite or right along. Um, but some of them you're going to have to work out by hand a little bit anyway. Okay. But somewhere write, if you can, write that answer down or somehow keep it. Because what I don't want you to have to retake the test if it goes away on you. Okay? So what I want you to do, what I told these guys this morning, is we just printed theirs out, and they said they could remember. They had 50 questions, and they said they could remember most of the answers, and they wrote them down. I don't know. It might have even already have given them the answers. I don't know. But I told them just they printed it out, and then they're getting it to me. For the distance ed folks, that's a little difficult. They'd have to print it, scan it, and then get it to me. But that's the best we can do. So whatever, don't panic. But again, if you would prefer, no, I'd really like to take it online. And can I do it again? Then I can open it up for you again. The problem is it might happen again. And the reason it takes me so long, remember I've been telling you for a while I'm trying to make this up, and you're thinking, yeah, well that old lazy ass, he can't get nothing done. Is that what you were thinking, or were you thinking something different? I'm sure you were thinking I was just lazy ass that can't get nothing done. Just as an example, I want you to look at this. If we look at the question bank, and here's for one category, there's a few questions. Okay? It doesn't say right here how many there are, but if you look under this and add these up, it tells you how many questions all this turns out to be here. Quite a few. So there's not one type of question where I've only got, well, there's one that there's only one. I'm not telling you which one it is. So you don't know what, that's the point. Here it says Boolean manipulation, right? But these are all the questions that it had there. That's all of them. There's not that many on that one. There's some like this random block 19. There are several different kinds here. Okay. That's what takes me so long. I don't give just one question. I give plenty of questions, and then I tell it to choose 3 from this bank and choose 5 out of this one and choose 2 from over here. And so you're all getting different tests. Okay. I mean, you're getting the same test in that I've got, let's say, if I've got 2 KMAP problems on there, then every test has 2 KMAP problems. But if you were sitting next to somebody and you looked over at his, which I don't want you to do, I really don't. But if you do, it would probably be different than yours. Okay? And it's not to try to keep you all from cheating. It is to try to keep you all from cheating. Okay. So, did I? What? Huh? Say what? I'm sorry? You could do that. If you got in a group of 5, chances are that
one of you might have
two of you would have, chances are, and some of them there's only three, so you would have, you and one other would have the same question, and somebody else and one other would have a question. One would be all by himself. Yeah, but but of course, please don't do that. Okay, you have the way I've got it set up for you guys is you have from 2 to 3:30 p.m. That's it. And if you look at it, where is it? If you were to look at this, you have 1 hour and 20 minutes. Now there are several ways I can set that up. What I set up is it's kind to you and just submits what you have and then throws you out. It could say you got 1 minute and you better submit, and if you don't, it throws everything out and you get nothing. Or it could not even warn you. It just throw you away. So I chose the one that said it would submit the test for you and you're done. Okay? But if you're taking it at the very top, and I don't like that, on the old Moodle, the clock used to follow you down. This time it doesn't. It stays at the top. But if you go back up and look at the top, it tells you exactly how much time Moodle thinks you have. Okay? No?
I love how you say Moodle thinks you
Right. I don't know if it's right or not. It's just what Moodle thinks you have left.
This fills me with confidence, sir.
I'm sorry?
This fills me with confidence, sir.
No, it really has worked out very well. I've taken it several times. It's just this morning when I saw those two students have it go away on them. And I know these guys are smart enough to get a lot of these questions right. And so to see it turned in and there's no questions correct, and I look and they're all blank. It's like something's wrong here, right? These guys aren't this stupid. I'm not going to say what I was thinking, but yeah. Say what? No. Some of you are probably stupid enough to get them all. That's a hard test. There's 50 of them, 50 questions. Anyway, you guys have only October 16th, that's Thursday, starting at 1:55. It'll be available a few minutes early. It'll be available a little late. I said till 4 p.m. But you only have, that's the time it's available, but you only have an hour and 20 minutes, period.
I have class
Directly after this. You'll have plenty of time.
So if I open it and
all that's saying is that if you, let's say you were coming back from a late lunch or something, or getting late.
Oh yeah, we're not coming here, are we?
No.
Okay, so we can just go to.
But I prefer if you guys are around here, so I can come on.
Okay, so
All right, we won't be coming to this class.
I forgot. I thought we were going.
Now, for the distance ed students, I did it a little different. I hope they don't all live in the same apartment together. I don't think they do. But they have several days to take the exam.
That's not right.
Okay? Huh?
7 days. We come to class.
But they don't necessarily know where each other live. So, don't any of you tell Zimke anything about the test, because he's in the distance ed class. That's why I said he couldn't be here today.
I was actually going to pay at the same time.
You can take it at the exact same time as these guys if you want to, but your class, and you're part of that class, has an extended time, because some of these guys are in the distance ed class because they work during the day, you know. Yeah.
If we can successfully answer every problem on the practice test, should we be able to?
You should absolutely be able to do this. Some of them might take a few minutes to do. Okay? So, now what you're saying is let's get on to the practice test and make sure that we did that right. Right? And the ones that I didn't do right, let me find out how to do it.
Remember the homeworks, like we were having trouble putting the format in, and you had to manually correct it.
That's going to happen.
Okay.
It's going to happen again. Okay? I can't help it. You will answer it sometimes a little different than I will. And if you look at it and you say, this is right, because it's going to give you the answers right afterwards. And if you think it was right, or if you disagree with my answer and you think yours is right, then, you know, you have the right to challenge me on that. That's fine. The other guys, though, they'll get a little bit more time to take it. Now let's take a look at the answers. You guys can get to the answers on this now. Okay, and there was a couple that some of the distance ed students asked me in particular to go over in some detail. Here, honestly, what I would do is I would pop it in the calculator. Why not? I said you could use a computer, use it. But now, something you want to be careful about. The calculator here for a -1, and you put it in binary, what does it tell you? Okay, you'll have to go in here and say it's scientific, nope, standard, nope, programmer. And then you get these. So you put in decimal 1, negative, and now you tell it hex, and you get that. Are you going to write down all those F's? How many are you going to write down? How do you know? What if it says an 8-bit number? Then you write down 2. If it says it's a 16-bit, you write down 4. If binary, look at all those 1s. How many are you going to write down? If I don't tell you, assume it's an 8-bit number. Okay? Assume what you see around there. So, like, if you see a big, long binary number, and you will have some conversions on there. So, go ahead and use this. Use probably all 8-bit numbers. Okay, this one. What I would do here, this one, and anything like this, you can do it however you want, of course, but what I did was said, it depends. I've got one in there that's got a NOR gate here, and that really messes everything up, right? But if it's an OR gate here, you can write A and B naught, or B and C naught. And then having that equation, you can real quickly look at this and be able to figure out this is where it goes, right? So that should be too hard to figure out. Hopefully I'm right on this, but we had A and B naught, and so there's a 1 right out of there. I don't have to go any further. It's a 1 at the output, right? Don't waste time on stuff that you don't have to do, or that you don't have to mess around with. If I see A's a 1 and B's low, so that's a 1, then this is a 1 and the output's a 1. I don't have to worry about what's going on down here. Okay, on this one, so here I could go in and look, okay, well, let's look at, it's actually, there's going to be a 1 and that's it. Okay, that I know for A and B. Now for B and C naught, B high and C low. Let's see, B high, C low. There's one. That's the only one. So those are the only three places it's high. And I didn't spend a whole lot of time on that. I talked more than anything else. Same thing here. I would do it as quickly and as simply as you can. You've got all of them ORed together. So look at the A, look at B naught, and I've got A is a 1 and B naught, there's a 1. A, now this must come from somewhere else. Here A is a 1, that doesn't look right. A and B naught, there's a 1. So, and I would draw them like this. That's why I said some of these you might want to have on paper and draw it out real quick anyway, you know. But the way you have to turn them in is like you had to uh, on that homework. You've got to write down 0 or 1 for each one of the times that I have listed here, right? You know what I'm talking about? Okay. Now, be careful, and because there was a couple of them that the best way for me to do it was to have more than 10 divisions. And so what I did was I'd put like 0, 1, 2, and then skip over to 3, 4, 5, and then 6, 7. So pay attention. They're not always right next to each other. You will have some like this. Now there's no way I can control. This one says 3 expressions you've got. One must be done using Boolean, one must be Carnot maps, and the other however you want. There's no way I can control that. So I just said, when those are there like that, just take them and reduce them to the minimum. If you like Carnot maps, use Carnot maps. Okay? Use it however you want. Do you have anything here that you have a question on? I mean, to me, it's always simplest. I think my preferred method is Carnot maps, and so what I always do is, huh? What the hell did he say?
Exactly.
You're lucky you don't have to hear the music next door.
Oh, okay. I'm sorry. I'm glad I don't hear the music next door. This is one of the reasons I would come in early if I could, and forget the music next door. I would come in early if I could, and set little things up like this, okay, so that we could, you know, when you come in here, now you can minimize this, and when it's time to do this one, you're ready. All you have to do is go, oh, okay, let's call this up. And the expression is A naught. Now, see, this has just got ABC. Well, I'll just use the upper 2. You know, I'll forget these. So we got, yeah, all 3 of them only have 3. Your test might have 4, though. So we got A naught. That's these 4 possibilities, right? And B, and that would be these, and then C, and that one there is a 1. And then we got A, that's those 4, and B naught, that's these 2, and a C, that's this one. And then ABC, that's this one. And then we got B and C naught. B is these 4, and C naught would be these 2. So we got 1 and a 1. All right, now that's as far as you have to go. This looks like a B, and then here is A and C not, right? Now, you write that out, and I've told you on there to write it out in a VHDL. So this should be B, and that one you don't have to put parentheses around. Or, because it's all by itself. Okay? Now for the parentheses, it should be A and not C. Right? And that should be what your answer is for this one. All right? And here I got, how did I get AC? Oh, that is C, not. Why didn't you guys stop me from doing that blunder in front of everyone? A, C, and B. Okay? Same for these. And if you can do it with just two, just use two of them. But I have four set up. And keep it there, minimize it, and next time, you never know, you might be able to come up with one. Okay, here, sketch the entity. How in the hell am I going to have you sketch an entity on a computer test? I'm not, unless I'm going to make everyone do a Word file too and submit that also, and then go sketch it and go scan it and then put it in your Word file and then send it to me. Sorry, you're not going to have to do that. Sorry. I wish I could make you do it, but I can't figure. I couldn't come up with a good way to do it. Okay. Then this one, if I gave you something like this, the worst case would be you might not be able to tell if these were all, if this was a line over all of them, or if it was a line over each variable. I know for me, if I did one of these, and if it was in the sum of products form, then this would have been a bar over each one of the variables, not over all three of them. Okay? It wouldn't have been not A and B and C, right? It would have been not A and not B and not C.
You said there will be appendices and then do it?
I'm sorry?
Can you repeat what you just said?
Okay, I won't have anything that is, let's do it like this. I will not have anything that's like not A and B and C, right? Which is like basically A, B, C with a bar over the top of it, or whatever, right? It's not going to be that. Okay, it's going to be more like not A and I can't type. I'm sorry. Not B and not C. Okay, that's what something like this would be. So it's just not going to be the other way. Okay. This is interesting. I didn't do any of these, but if I did one of these, I could put this up there, and I could give you, the possibilities on the side, like where we have on the waveforms where you have 0 or 1 are the possibilities. I could have up there that the possibilities are A, B, not C, C, 1, and 0. I could have all of those possibilities. And then say, tell me what is connected to S0, what's connected to S1, what's connected to input 0, input 1, input 2 or 3. Okay? And I would have a picture of this and tell you how to do it, or tell you how to connect. Do you see what I'm saying? No. Okay, go.
Oh, go. I just said no. Those numbers on the left, like 1, 0, 0, 1, etc. Like, where does this come from?
Okay, where did this come from? Okay, if we come back up here and we take this expression and we come up with its truth table, right? If we did that, actually the easiest way to come up with the truth table would be to expand them all to 3 variables, and that would be this, and then we'd have A, B, C naught, and we'd have A, B, C again, and then this one, and then that one. Convert that over to numbers, where if it's got a bar over it, it's a 0. So this would be 0, 0, 0. A 1 would be there. A, B, C naught would be 1, 0. I'm sorry, 1, 1, 0. So at a 6 would have a 1. Following? A, B, C at 7, there would be a 1. This would be 1, 0, 1. So that's at a 5, we would have a 1. And this is a 3, we would have a 1. Okay? So, if your truth table, you could have it written that way. But look what I've got here. I had 0, we had a 1. So when I select, by having A, B, and C low, when I select input 0, I want the output to have a 1, and that on a multiplexer. So you have to know how the multiplexer works, right? So you have to know that part. So here, that whatever is on input 0 goes to the output, goes to 1. So we've got the next one, which I said was A, B, and not C. That would be 1, 1, 0. That's a 6. 6 has got a 1. Okay. When we have A, B, and C, that's when there's 7. Okay, there's a 7. 7's got a 1. I'm doing this in my head. Am I confusing you? A little bit?
I just have a quick question.
Okay.
Do you want us to actually, make the actual logic gates, do you want us to put the inverters in there too?
No,
Or
I'm
do you
not
just want
gonna.
Just to put the and.
No,
Oh, we're not doing that.
I would give you, if it was something like this, one of the options to connect here would be not C, and the option to connect here would be C, and then there would have to be a 0 and 1 option, so that you could choose 0 and 1 for these, and or A and B would have to be options also.
Okay.
All right. Because this could be, you could have these switched around and have A down here and B here. And then I've got, A is S0 and B is S1, so these get reversed. So I might not have both answers in there, and then that's one of those where you have to tell me to go look at it and regrade it. Okay, Jordan, you were asking a question.
Yeah. I'm still confused about the 0, 2, 1, 2, 7.
These right here?
Yeah.
Okay. So what we've got, let's do it this way. I've got the expression here. We have, let me go ahead and take a moment to type in the expression. I know it takes a little longer, but that's not A and not B and, not C. But if I were to do that in, if I was to put that in here, where would the 1 go? In which cell? If let's say that we just have these three, or the as a 3 variable K map, which cell would that go into? Top left, cell 0. So a 1 goes there because this would all be, we would look at that as a 0, 0, 0, right? And then we would have or AB. Now this one we got A and B. Now we can stop right there and say, well, that goes where? It goes A and B would be here and here, but that's 6 and 7. That's the same as multiplying this out and saying you don't have to do that if you don't want to. A and B and not C, and the other one would be A and B and C. That's if I, basically what I'm saying is I multiply through here C or C naught.
Oh, that's why, okay.
You see that?
With 107?
So that would be 6 and 7, those cells.
Yeah, well, that's why I like to answer that.
Okay, and then this one, where does this one go? A and not B and C. Well, that goes in cell 5, right? And that's right here, right? And then the last one is A and, or I'm sorry, not A and B and C. So that's a 3, and 0, 1, 2, 3. So there should be a 1 there, right? So let's say 1, 1, 1, 1. That's where all the 1 should be for this particular one. Now, for the multiplexer, I have A as my most significant, then B, then C. So I have it fixed. The same as this, it works out the same if A is the most significant to have this 3-bit K-map. Okay, so this matches the A being the most significant, then B, then C. Now, cell 0, bit 0. We say it's a 1. When I've got not A and not B and not C, that's what I have here. That's what I got here. I've got a 1 that should appear on the output. When I've got, if I've got a 1 that had a 0 in it, that's 1, bit 1 has a 0. So when I select a 2 here, that's this cell, that also has a 0. So when this is selecting a 2, it better have a 0 tied to it. Is this starting to make a little bit of sense? Yeah, basically. And the way Xilinx works is it comes up with the LUTs. What does that stand for? I know, and now I'm not remembering. What's the LUT mean? I know it's LUT. I'm not that stupid. I know it's not loot. I forget what it means, but it's like a truth table basically is what they're telling you. And it's also the same as a multiplexer. So all the way through here, here's 3, it's a 1, here's 4, it's a 0, 5, 6, and 7 are all 1s. Okay? Now, this gets a little bit crazier. If I say take that same circuit but implement it on a 2-bit, I'm sorry, a 4-bit multiplexer. I did that on one of the earlier slides, right? Do you guys remember that one? I did it on this set of slides. Let's see if I can, it's in here somewhere. Oh, let's go page down. Okay, and we've got to come back to some of those other ones too, but we did them here, right? Here's where we did it. And we did it here. This is probably the best example is right here of going from a 3-bit multiplexer and implementing it on a 2-bit or a 4-bit multiplexer. This is an 8-bit, this is a 4-bit. Sometimes I mess up and I say how many inputs it has. But this is like A, B, C. A is the most significant, then B, then C. And I can say A is the most significant because I say that's 4, not 1. Right? Yes, sir.
Did you ask for simplified or just original expression?
No. Some of this kind of thing you don't simplify. If you simplify it, then you have to expand it again, and then you're going, what the hell did I just do that for? You just wasted a bunch of time, is what you did. So this would be like I just did with that example on this this Carnot map, and where is that? I had another one. Didn't I have two? I messed up, didn't I? Okay. Oh, I have it. Where's the test? Did I throw the test away? There should be two. Okay, anyway, let's sorry, let me get out of this for a second. There it is. Here's that exam. So if this is exactly like this kind of a truth table, okay, we set it up for 8 inputs. We've got when we've got 0 here, I had a 1. I don't have that on this one. I have a 0. But it's this page 37 of 58 is the example of how to do that. Then so what I did to move it to a 4-bit multiplexer, I said, well, let's use W3, or in our case it would have been a C, as one of the inputs, as one of the possible inputs. So if C is a possible input, I've got AB. Well, AB is 0, and there's 0. And then I come over here and I look, and it's like, well, either case it's 0. So I put a 0 at the input. Does everybody see that? And then here, I've got A and B are 0 and 1. And the output matches what would have been C if this were C. Right? This output matches C. So here W3 is a C, so there we go right there. It's connected straight to it. So that when I select 0, 1, that's pin 1 there, it gets that one. Same thing happened on this set. When I had 2, I got that. And here where I had 3, the outputs were 1. So I got a 1. So that's what I did on this practice test. I said, I looked at this as a truth table, and it would probably be better to go ahead and draw out the truth table. Don't you think? I think that would be an easier way to do it. So when I've got 0 and 1, C, it would be C bar, because in the C slot would be 0 and 1, not 1 and 0. So that's C bar. When I've got 1, that looks like a C to me. When I got a 2, this looks like a C to me. And when I've got 3 connected there, no matter what, it's a 1. Does that make sense? No, there's a couple of you that are going, no, that don't make any damn sense to me. It's, okay, study this. If you got some questions on it, email me, and what I might try to do, it's probably on my website too. Don't I have something on multiplexers that shows you how to do this? So go look at those tutorials, and if you still don't know, then you can either say, oh hell, I'm going to miss a couple on the test, or I can take a damn good guess, or you can start praying now and ask that there's not going to be any like that on the test. You could slip me some money.
Hey, I've got 30 right now.
There are several ways we can do this, okay? The other thing is you can just learn this. It's not that big a deal. You're making it a bigger deal than it is. Okay, where they start getting hard is right here. Okay, now I shouldn't do this. I shouldn't do it. But I'm going to be very nice to you all. Pierre's jumping right in there. Thank you. Thank you. I do want to go into some explanation about this. So let me explain this first. Okay. Here's a decoder. Do you remember how a decoder works? Okay, then you're going to have to go and look at those PowerPoint presentations that tell you, I mean, I would start studying how does a decoder work. And here's a decoder right here. Enabling is a 1. If the enable has a 0, doesn't matter what's on the outputs are always inactive. If these had had a bubble on them, the active state would be 0. And this would be 1s. Here, the active state is 1s because there's no bubbles. So it's inactive because it's not enabled. When it is enabled, we choose what's here, 0, 1, 2, or 3. And that tells which one of these outputs becomes active. Well, that's what we're doing here. Now that looks a lot more complicated than it is. So the first thing you do is look here. And I see an enable, and it's enabled when it's high. So I don't need to worry about that. All these are active high, so this one's, it's not enabled. They're all low. I come through here and I go, ooh, all these times it's not enabled, they're all low. And look at them, they're all low there. And then I come over here and all this part where it is enabled, now I have to go look at these two inputs and say, what value is this? Well, if W0 is the lower bit and this is the higher bit, then that 0, 1, this is a 1, and line 1 goes high. Do you see that? With this, I've got 1 and then 0. So line 2 goes high. Only one of these will be high at a time. If you get more than one high, then you're making a mistake. This is extremely complex, and I'm not putting one of these on the test. What was nice about that, there's two levels of that. Okay, one is I didn't put it on the test, but the other is I'm telling you that I'm not putting one on the test. So you're not going to go out and spend a lot of time studying this and then find out there's not one of these on the test. I do want you to know how these things work, and I hope by repetition, by the end of the semester, you will know how these work. Okay? Now, an adder. One of my students in the DE class asked me to please go over this thing for him. So that's what I'm going to do. You have to look at this. You got to know how these work. We got four inputs. This is A. This is B. There's the output. It looks like I'm going to have to zoom in a little bit here to see what all's going on. Can you all see what's going on? This looks like a carry in, and this looks like a carry out and an overflow. Okay, so now let's bring it down a little bit so we can see these inputs. Look at this. Carry in, I only had one of them. So look for those kinds of things first, okay? Then we've got, during this section, I got A, 0, 0, 0. A is 0, B is 0. If I add them up, I get 0. Do you see that? These look so much harder than they are. They're really not hard. Now, by the looks on your faces, you guys didn't really work too hard on that practice exam, did you? Did you? It's all right. No, it's not all right. I wanted you to work on it.
Well, that's why I told you I have only 6.
You tried it,
Yeah,
but
I tried it.
but you didn't get this.
No.
Okay. All right. So do you see what I'm talking about now, though? So here on this one, let's look at the next one. If you have to, seriously, if you have to, print that out real quick. Take 2 pieces of paper and cover this up and cover all this up so that you're only looking there. Okay, so you're focusing on that one part. And I've got 0, 0, 0, 1. I've got 1 plus 0, 0, 0, 1. I got 1 plus 1. What is that? That's 2. I got 0, 0, 1, and 0. That's a 2, right? And there's no carry out. Then I move on to this one. I've got, look at this. Look at this B. All the way across here, I've got 1, 1, 1, 1, 1, 1, 1, and a 0. So all these are 1. Now let's see what I got up here at A. I got a 1, so 1 plus 1 is 2. Then here I've got a 2, and 2 plus 1 is 3. And oops, look, got a 3. Then I got 3 plus 1 is 4. You're starting to see how this is not as bad as it looks. It's complicated. It looks a lot more complicated than it is, right? Here, what have we got? Is that a 4? That's 1, 0, 0. Yep, that's a 4. Plus 1 is 5. So and none of them have a carry out.
Please keep it like that.
Huh?
Please keep it like that on the test.
Okay, does everybody see how this works? Now we get down to the end, and then I've got a couple of things going on. It's starting to get complicated down here. So I did even though it may not look like it, I did try to keep it easy at the beginning and then toward the end. So if you missed anything, it was just a couple of them at the end. Okay? And I'm going to grade it on each time division. Okay? So this one here might, I don't know, it might be worth 15 points. Okay? And then, so that would only be, if you only missed the last 3, you would have got 12 points out of this instead of 15. That's no big deal. But let's look at the last couple here. I've got let's see, that's a 0, there's a 1, there's a 1. So this looks like, what is that? 0, 1, 1, 0. What is that?
What did you say? 0, 1, 1, 0?
It's
6.
0, 1, 1, 0. That's a 6 on B. And what have I got here? It's looks like a 0, 0, 0, 1. So now I switched the complexity. I put the easier one on A and the harder part on B. So 6 plus 1, I got bing, 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 7. Now here, the final one, I put a carry in. It's the only one with a carry in. The only one. And we've got 0, 0, 0, 1. A has 1. B has 1, 1, 0, 1. What is that? Has a let's say, what is that? 1, 1, 0, 1. 1, 1, 0, 1. That's not working. And I add 1 to it, and I get 1, 1, 1, 0, right? And then I add my carry in, and I get 1, 1, 1, 1. So I get 1, 1, 1, 1, and no carry out. You understand all that? Yes, sir.
It looks like the last part of B3 is missing.
Say it again.
It looks like the last part of the B3 wave.
This last part?
Yeah, like COB3 is like flat line all across, and then it's missing.
Well, it's kind of hard to see. Is that it?
That's what the CN. No, that's the
CN is a carry in.
Yeah, I know it's what it's saying, but yeah, B3 doesn't.
Okay, so we got to follow all the way across here. We see it's always 0, and then here it goes 1.
It's on the same line with B3 though.
No, now B3 is right above it. So this is 0, and that goes 1. Now that one looks bad.
Yeah,
And now, if I tried not to do that on the test, you'd be able to tell them very clearly. What I would do to make my job easier on this one is separate A from B from C in. And then I would put somewhere in here like, this is 0, this is 1, this is 2, 3. I would have those decimal numbers written in those time slots. I would do the same for B. I would do the same for CN. Then I would add them in decimal, and I could easily figure out what the bits need to be. Now, listen carefully. I did not put an adder on the test, because if I did, you would have spent all your time on the adder. Okay, I do want you to understand how they work, but I didn't put one on the test. I did, however, put S and R flip-flops. I did put D flip-flops. I did put T flip-flops, and I did put JK. Okay? I had some that had positive edge clock, some that had negative edge clock, some that had level. Okay? Now, I don't know why I'm doing this. You guys haven't given me any money.
Yes, I did.
Last time you tried, I wrote you a check.
But I only put one level flip-flop, positive level triggered, and that was a D. Okay, so let's look at that one. That's this one. Okay. Now I don't remember what my all my waveforms looked like. I have no idea what that looks like. But I've got, this says right here, there's no triangle there. So that tells me it's a level triggered flip-flop. It does not have a bubble. So it's positive level triggered flip-flop. D flip-flops, the output follows what is on the input. So here the clock is low. Q, I start off every one of them with Q being low or high. And I think all of them I started with Q being low. So here it's low, it's low. Now all of a sudden the clock goes high during this whole time. And if I were you, I would mark that. This is the part that's important right here. Just draw a straight line. Take a crayon across there. I don't care. Something to tell you. Focus here. And then say, okay, well, here's where it's enabled. D is 1, the output's 1. D is 0, the output's 0. D is 1, the output's 1. D is 0, the output's 0. And I can sing that song for a little while longer. We get here. D was 1. The output's 1. Our trigger dropped to 0. That means the output doesn't change anymore until the next trigger. Right? So it was a 1 right before then. It stays a 1 all the way through there. You don't have to look at that at all. You don't have to think about that at all. You just write a line across there. Okay? Then, we have another part where we have to focus. It's level triggered. It's positive level triggered. All this time, D is low. So Q is low. D went high, Q went high. D went low, Q went low. D went high, Q went high. D went low, Q went low. D went high, Q went high. Then the trigger stopped, and it doesn't matter what's going on here. This was high. It stays high until the end of the game. Okay? I have in our slides the flip-flops. There's one page in here where I've got, I forget all this stuff in the beginning. That's just trying to explain how it works. Get to the point in here where you see S&R flip-flops and some of these clocks and stuff like that. This is level triggered, right? So we look at what's going on there. Okay, here. Keep looking and keep going down. Here's the one I'm looking at is page 43 of 79 in the flip-flops. I've got a positive level clock, or D. I got a positive edge triggered D and a negative edge triggered D. I can tell it's edge triggered because it's got that triangle there. I can tell it's positive because there's no bubble. I can tell it's negative because there is a bubble. Okay? So, when it's a positive edge triggered D, the clock changes only on the positive edge of the clock. There's only two places in this whole thing where D changes. Here and here. So I would draw something there. I'd get out a big red crayon or something and draw a line there and a line there and say focus at these points. And then here I see that for this particular one, QB is low all the way at the beginning because it started low. The positive edge happened and D happened to be high, then QB goes high. I draw that straight line all the way over to the next time that I get a positive edge on the clock. And then I look there, what is D? D is low, Q goes low. I only had to look at two places on that one. On this one, I only look where it's active low. Well, here, QC started 0. I keep it 0 until the first time the clock goes low. Well, D was low. It stays low all the way up to here where I see the next negative edge. And here, D happened to be 1, so it went high. If D was 0 here, it would have stayed low the whole time. Okay, now let's look at those. So here, what kind is this? Positive edge triggered D flip-flop. I made this one look so damn complicated. And you have to look here and here. That's it. D is a 1 here. Q goes high there. It stays high until this point, and I look, and D happened to be low, so Q went low. That's it. You write down a bunch of 1s and then a bunch of 0s. Here, negative edge triggered. You look here and you look here. Now, there may be more on your test. I don't know. I can't remember. I can't remember how many there were. There were probably several. Okay, do you remember how a JK, SR work? SR, the illegal state is when they're both high. I didn't put any illegal states on there. Okay, so they're all, something should change. When S is high, it gets set. When R is high, it gets reset or goes to 0. When they're both low, it stays the same. This one, positive edge triggered. You look here, 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 and here. 5 places. That's it. T's. Do you remember how a T worked? This is probably, to me, the most the hardest one for me to work with. It's just a little complicated. It's not complicated. It's just, after all, the way the other ones work, this one messes me up a little bit sometime. But remember, I'm on a lot of heavy medications. So you don't have that excuse. Unless you're at home taking the test and you're drinking and doing other kinds of drugs. I wouldn't do that during this test. This shows negative edge triggered. A T, if the input is high, a T toggles. That's what the T stands for, is toggle. If the input T is high, the output toggles. If the input is low, it stays the same. Toggles or stays the same. So here, we only have to look here and here on the clock. So Q started low, it stays low to here. I look here, T's high, it toggles. I draw that line all the way over to here where it went low again. The clock went low, and I look, and T is high, so it toggles. It's really not all that hard, is it? JK. You look here. Is it edge triggered? Is it level triggered? Or is it and then is it positive or is it negative? What is this? It's a positive edge trigger JK flip-flop, right? Give me just a minute or so. I know some of you guys got class, but this is the last one. So we only have to look here, 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 and here. 5 places. Starts low. When J is high, it gets set. When they're both low, there's no change. When they're both high, it toggles. They're both high, it toggles. When J is low and K is high, it's reset. Okay? You will have probably both the JK positive and negative edge triggered. You'll probably have an S and R both positive and negative edge triggered. You will have a T positive and negative edge triggered. Ooh, starting to sound like it's going to take a little while, doesn't it? And then you will have a D that's level triggered, edge triggered positive, and edge triggered negative. Now, so what I would do, first thing, you get that test, print it, then go back and start working on it. Okay? Huh? Say what? Well, it's going to be hard if you're all in the lab, right, printing it. But if I would do something so that you can show you can do something, unless you can keep all that straight in your head. I'm just trying to give tips. But if you can do it, print it out, and then mark on there where you have to look. Thursday's test. Good luck. I told you guys a lot more than I should have told you today. Just the right amount, huh? Okay.
That's the part that really matters.
If the DE students, if you guys have any problems or questions, please email me, and I'll try to answer it the best I can.